Today on How It's Made. Electric stand-up vehicles. Frozen fruit. Beer coasters. And forged door handles. In the 21st century, there's more than one way to chase down a perpetrator. The electric stand-up vehicle goes where traditional police and security cars can't. Sidewalks, parks, shopping malls, even airports. The officer stands for better visibility. For a suspect, there may be nowhere to run. This electric three-wheeler is the latest thing on the police beat. Not only can it travel in areas that are inaccessible to cars, but its environmental footprint is lighter than a regular police cruiser. It's energy efficient and it generates no local pollutants. Production starts with the vehicle's frame. An employee assembles the tube steel parts and welds them together. The next worker attaches the vehicle's control board panel to the welded frame. He inserts the steering shaft into the column and slides a plastic collar onto the bottom of the shaft. He secures the collar with screws and tightens the adjustment mechanism. He installs a second collar on the upper part of the steering shaft. The two collars will stabilize the shaft to keep the front wheel of the vehicle straight. He plugs the electric motor cable into the control panel. Next, another member of the team sprays a uniform layer of a gel coat onto a two-part mold of the vehicle chassis. The gel will act as a release agent for the finished chassis. They make the chassis from fiberglass. He sprays it evenly into pieces of the molds. He presses out air bubbles using a rubber roller. Fiberglass dries and solidifies, taking the shape of the mold. The surface is smooth, but there are some ragged bits around the edges. Those are sanded. He cuts out a slot in the upper part of the chassis for a police warning light. Finally, the chassis gets a coat of automotive-grade white paint. He paints the wheel wells black, and with that, the outer chassis is complete. There's an interior panel, and it's made of fiberglass too. A member of the team mounts it to the inside of the steel frame assembly. He then secures the outer panel to the vehicle frame. This electric three-wheel vehicle is ready for the rear wheel hubs and brake rotors. He clamps brake calipers to the rotors. The wheels are next. The rear ones are motorcycle wheels. For the front, they use a golf cart wheel. He equips the wheel with a pulley system to transfer energy from the motor. He installs the 1-horsepower motor and attaches the pulley to it. The motor is the size of a lunch bucket, but can pull up to 450 pounds and reach 20 miles per hour. He hooks up the front wheel to testing equipment and powers up. It evaluates the motor speed and noise. It also detects any undue strain or wheel wobbling. Satisfied with the front wheel assembly, he installs it on the vehicle. He wires and then attaches the throttle and brake control to the handlebar. They carpet the floor with non-slip rubberized foam. and then slide the 2 rechargeable batteries into their respective compartments. The charge time is 3 to 4 hours. Next, this grab handle gives the driver something extra to hang on to. They equip the vehicle with warning lights and a high-beam headlight. This electric patrol vehicle has been 6 hours in the making, and it's now ready for a spin. Nowadays, you don't have to wait for your favorite fruit to be in season. You can buy it year-round in the freezer section of your local supermarket. Frozen fruit is useful to have on hand for baking, for making fruit salads or smoothies, to use as a topping, or to eat as a healthy snack. Timing is everything. For example, strawberries, when sold fresh, are picked well before they're ripe, so they won't spoil before reaching store shelves as much as a week later. But if the berries are for the freezer section, they're harvested when fully ripe. That state of perfection will be frozen in time within 36 hours. Farm workers pick the berries by hand and trim them right in the field with one swipe over a sharp stainless steel blade. Within 90 minutes of harvesting, the strawberries are on their way by refrigerated truck to the nearby processing plant for cleaning, sorting, and quick freezing. First up on the processing line, a bath in fresh water to remove field dirt. This wheel gently submerges every last strawberry. Then a shower of clean rinse water, followed by a spray rinse with highly chlorinated water to sanitize the berries. Next, eagle-eyed workers pick out and discard any bruised or underripe berries. The rest receive a final rinse en route to the freezing tunnel. Temperature, -34 degrees Fahrenheit. The cooling coils contain liquid ammonia, a refrigerant commonly used for industrial-scale freezing. Inside the tunnel, where the frigid air circulates at high speed, the berries freeze in about 20 minutes. Upon exiting, they ride through a sorting machine. The smaller berries drop through narrower gaps between the rollers near the top. The medium-sized ones through wider gaps partway down, while the larger ones continue to the bottom. These peaches, also hand-picked when ripe, go through the same cleaning process as the strawberries. First a bath, then a shower, then a sanitizing rinse with chlorinated water. After workers pick out leaves, twigs, and any less than perfect fruit, a sorting machine sorts the peaches by size, small, medium, and large, sending each size to a separate conveyor belt. Each belt leads to a different line of stainless steel pitting machines, adjusted for the size of the incoming fruit. First, the machine places the peach's stem down. Next, a knife cuts the peach in half along its natural line. Then, mechanical jaws grab the stone inside and dislodge it by twisting the 2 halves of the peach in opposite directions. Each machine can pit 90 peaches per minute, so the only way that action is in slow motion. All the peach halves and stones coming out of the pitters tumble onto a vibrating conveyor. The stones fall through the holes while the peaches, larger than the holes, continue on. A conveyor flips them cut side up so that workers can inspect and remove any stone fragments. The next conveyor gradually lines them up in single file to enter the slicing machines. The slicer blades cut each half into 4 to 6 pieces, depending on what format the customer ordered. Then the slices go into the freezing tunnel. Peach slices take slightly longer than strawberries to freeze, about 25 minutes. To prevent the frozen fruit from defrosting, the air temperature in the packaging area is a frigid 39 degrees Fahrenheit. An automated scale weighs out the per package quantity, then drops the berries into a retail bag. The machine then heat seals the bag and deposits it on the final conveyor, which goes to the pre-shipping freezer. Only 15 minutes have passed since the fruit was frozen and just 24 hours since it was field picked. Liquid refreshment can leave its mark on the table. Coasters come between the glass and that. But 2 centuries ago, coasters were mainly placed on the rim of the glass to keep out flies. Made of felt, they unfortunately spread germs. So the cardboard coaster was invented to improve hygiene on the pub scene. Beverage coasters protect the table and are also a marketing tool. Raise the glass, and you'll see advertising catchphrases and promotional graphics. In fact, some bar hoppers consider coasters pub art and accumulate vast collections. Production at this facility in Germany starts with spruce wood. In this case, it's from the Black Forest nearby. They spray the wood with water to moisten the bark. Then it's into a tumbler that tosses the wood logs. As they knock against each other, the bark peels off. The debarked wood exits onto a conveyor with slots to correctly orient it for entry into a massive grinder. Inside, chains press the wood logs against the grinding stone, shredding them into chips. Water flows over the grinding stone to cool it and carry away the chips, which are then mixed into a mash that has a porridge-like consistency. It's pure wood pulp. They now add leftover product from previous beer coaster production to the pulp. This will be used to make the middle layer of the beer coasters. Finally, they mix residual paper from the manufacture of magazines and envelopes with water. This creates a lighter colored pulp. It will be used for the printable surfaces of the beer coaster. They spray the pulp onto a mesh that drains water from it. The fibrous wood core goes between the layers of the lighter pulp. Spigots apply a mix of wheat starch and water that acts as a glue between the layers. Off the mesh conveyors now, the pulp board travels between cylinders that squeeze out the moisture. More heated cylinders dry it. Knives now cut the board into large rectangles, sized for the coaster printing and cutting machinery. This specialty cardboard is known as wood pulp board. It's lightweight yet highly absorbent. Next, it's over to the printing department to put the beer coaster artwork on the wood pulpboard. They use offset printing, a process that involves more revolving cylinders. Color cylinders pick up ink and transfer it to the printing cylinders. From there, the image goes to a rubber-wrapped cylinder that then prints it onto the sheets. A print specialist scrutinizes the print job close up with a magnifying glass. He checks the color and clarity of the images and confirms that they're correctly positioned on the sheet. The borders of the images must line up with the grid of blades on the die-cutting machinery. If the alignment is even slightly off, every coaster on the sheet would be ruined. As the die cutter punches out the coasters, dozens of them in one swoop. The coasters end up over little chutes, and pushers give them a nudge. They fall down the chutes and land neatly on a pallet below. The coasters stack up, and when there are 100 or so in each pile, they're ready for packaging. Machinery shrink wraps the stacks, and they're ready for the thirsty masses. This factory can produce and package 10 million offset printed beer coasters every day, so there should be no shortage at cocktail hour. They also print coasters using a centuries-old technology known as letterpress. Blank coasters drop down into the machine. A rolling wheel presses each coaster against an ink plate. It's a system that both prints the image and embosses it on the cardboard. It's a difference you can both see and feel. Letterpress production is lower volume than offset, generating 100,000 coasters per day. For coasters, the design possibilities are endless. Just raise a glass and enjoy. A door handle is a decorative detail that delivers tremendous bang for the buck. It's quite inexpensive, yet through its design, material, and finish, contributes immensely to defining the style of a space, from traditional to ultra-modern. These hand-forged iron handles open the door to a rustic English country decor. While the handle itself is iron, the backplate behind it is steel. A computer-guided water machine cuts the backplate out of a 3mm thick steel sheet. The machine slices through the steel not with a blade or saw, but with a concentrated high-pressure jet of water. The water contains a tiny amount of a superfine abrasive and cuts through the steel with 2,000 times the pressure of a car tire. The jet cuts the contour of the backplate, then holes for the key, the mechanism, and the screws, which affix the plate to the door. Next, with the beveling machine, they cut a neat angle on all four sides of the backplate. This smooths the sharp edges and gives the backplate a finished look. Meanwhile, on a computer-guided lathe, a knife progressively shapes a round steel bar into the main component of the door handle mechanism, the inner barrel. The next tool bores a hole in it to receive the spindle, a bolt that runs through the door, connecting the handles on either side. To make the handle, a blacksmith heats up an iron bar in the 1600-degree heat of a forge and hammers it to a tapered point. Then, he repeatedly reheats and works the iron, hammering it some more and bending it against a steel forming jig. With each bend, the handle comes closer to the final shape. Once the blacksmith has completed his work and the iron handle has cooled, they drill a hole to receive the mechanism. Then, with another tool, they angle the edges of the hole. This increases the surface area to which they now weld the mechanism's inner barrel. The larger the welded area, the stronger the weld. The welder places both components in a positioning jig to get the proper alignment. Then welds them together. He removes the assembly from the jig, flips it, and welds from the other side. They grind the weld lines flat, rendering them unnoticeable. If the handle is supposed to have a hammered finish, this is when they create that texture with, you guessed it, a hammer. Now, they heat the handle assembly and the steel backplate in the forge, then dip them in a vat of beeswax. This protects against rust when used indoors. With the main components now ready, final assembly can begin, starting with the mechanism. They slip a nylon washer, then a steel spring over the inner barrel. Next, they grease the outer barrel made of forged iron and place it over the inner barrel. The washer in between the barrels eliminates friction when they move against each other. This prevents the barrel from wearing out and squeaking. They install a tab washer made of nickel-plated steel. This tab restricts the barrel's rotation so that it doesn't simply spin around and around. This high-strength steel locking clip holds the inner and outer barrels and that important tab washer in place. Now that the handle and mechanism are complete, all that remains is to align backplate to handle and secure it in position with screws. Each retail package contains 2 handles and 2 backplates, one for each side of the door. Also in the box, the steel spindle that goes through the door, connecting the barrels so that the handles turn in unison to retract the latch and open the door. While their mechanics are hidden from view, these hand-forged handles are certainly a sight to be seen. If you have any comments about the show, or if you'd like to suggest topics for future shows, drop us a line at sciencechannel.com/howitsmade.